All right, today we're going to talk about zeros of polynomials. So we're going to go to higher degree polynomials and talk about finding the zeros of those. So we've got to review a couple of skills that we're going to use to do that. The first one is long division with polynomials. We'll use this later in the chapter, probably more so than you'll use it this section or these two sections, but do need to review long division, and then we'll do synthetic division, which is what you'll use most of the time. X to the third minus 4x squared minus 5 divided by x minus 3. Okay, if we're going to do long division with that, let's set it up. X minus 3 on the outside, that's our divisor. Our dividend, or what we're dividing into, goes on the inside. X cubed minus 4x squared. I need a representative from every power down to where there's no x's. So I got x cubed, I got x squared. I'm missing an x, so I'm going to put plus 0x in there so that I've got a placeholder for that because I'll need that later on. And then minus 5. Okay, so I'm just setting it up. Again, if there's a missing term, either in the dividend or the divisor, then you need to put a 0 with whatever piece is missing in its place. The same rule applies when we do synthetic division as well. Okay. If you remember how to do long division, you really only have to look at the front of each polynomial. So the first term of our divisor is x. The first term of our dividend is x cubed. So what times x would give me x cubed? X squared. So an x squared is going to go up top. And then I'm going to take my part of the quotient here, and I'm going to multiply it times everything that's in the divisor. So x squared times x is x cubed. X squared times negative 3 would be minus 3x squared. We'll put that in parentheses and subtract. The x cubes cancel out just like we want them to. And then we're doing negative 4x squared minus negative 3x squared. So that's a double negative there. So that's negative 4 plus 3, which would be negative 1x squared. And I'm going to bring down the 0x. I'm bringing down just that term because what I'm dividing by only has 2 terms. If what I was dividing by had 3 terms, I'd bring down enough to make a 3-termed polynomial there. And then I go back to the front. What times this x gives me negative 1x squared. Negative 1x, yeah. And then I distribute again. Change colors here. Minus x. That'd be negative x squared plus 3x. And I subtract that. The x squareds cancel each other out. 0 minus 3 would be negative 3x minus 5. I'm bringing down that minus 5 from up there. That's where that's coming from. And again, I go back to the front. What times x gives me negative 3x? Negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Parentheses and subtract. The x's go away. Negative 5 minus 9 is negative 14. That is my remainder. And the remainder, we know it's a remainder because there's nothing. If I multiply something times x, I'm going to get an x on it, right? That doesn't have an x. That degree is lower than the divisor's degree. So that's how I know that I'm done doing division. I've got a remainder. The way that we write remainders and quotients in long division or any kind of polynomial division, you've got your quotient here, the x squared minus x minus 3, and then you're going to add negative 14 over x minus 3. So you write it as a fraction. Remainder over what you divided by, always. And I usually use a plus sign and use a negative on the top if necessary. You might see that written as x squared minus x minus 3 minus 14 over x minus 3. This or this are correct. Using long division to do that one. Long division, it has a very bad name. Nobody likes doing long division. I don't think it's that hard. It's a lot of steps. This same problem can be done using synthetic division because the divisor is linear. If the divisor is linear, then you can use synthetic division. So we're going to do this same problem using synthetic division, which is much easier. Most or all of you should have seen synthetic division for sure. Hopefully enough long division in Algebra 2 to be familiar with that idea. But if we do the same problem using synthetic division, we're taking x cubed minus 4x squared minus 5 and divided by x minus 3. So same rule, or the synthetic division is going to should get us the same result. We should end up with a remainder of negative 14 at the end. Our quotient should be the same because it's the exact same problem. We're just using synthetic division instead of long division. So when you set up synthetic division, y'all remember doing that? Got the little number on the shelf, and then you got the coefficients of the polynomial go on the top row. All right, so on the top row, we're going to have 1 for x cubed, negative 4 for x squared, 0 for plain x, and negative 5 for the constant piece. So an x cubed polynomial should have 4 terms there. Fill in the missing ones with zeros out of that. Now, to get the number that goes on the shelf, we take the divisor and set it equal to 0 and solve it for x. So positive 3 is what goes on the shelf there. If you remember, you change the sign of it, that's fine too. It's always the opposite sign. Okay. Now, synthetic division. Does anybody remember what your first step always is? Bring down the first term. So that 1 drops down. Then what do? Yeah, 1 times 3, and that's going to go right here underneath the negative 4. So 1 times 3 is 3. And then what operation do you do? Addition. Always add in synthetic division. In long division, it's always subtract. In synthetic division, it's always add. So negative 4 plus 3 is negative 1. Multiply negative 1 times 3, negative 3. Add 0 plus negative 3 is negative 3. And then we're multiplying negative 3 times the positive 3. So that's negative 9. And we add those together, and that's negative 14. This number down here on this end is the remainder. These are the coefficients of the quotient. What does the synthetic division do to the polynomial? Drops it down 1 degree. So it started at x cubed. Our quotient is going to start as x squared. Anytime we do synthetic division, it takes it down 1 notch. So that's going to be x squared minus x minus 3 plus negative 14 over x minus 3. Same answer that we got there in example A, but using synthetic division to get it. Synthetic division can be used if the divisor is linear. If the divisor is quadratic or bigger, you cannot do synthetic division. You have to do long division. Okay. So synthetic division is what you're going to use most of the time in this first part of this or these 2 sections. But long division is something we're going to have in this chapter 2. So I just kind of review them together, and we'll get more use out of the long division later on in the chapter. But this synthetic division is what we're going to use most of the time. Okay. All right. Hopefully you remember those. If you don't, it's not a hard thing to pick up. All right. Next thing we're going to talk about is breaking down a polynomial by factors. And so we're going to talk about the factor and remainder theorem. factor and remainder theorem. Definitely the abridged version of that theorem. The factor and remainder theorem says that x minus c is a factor of the polynomial if and only if, when you plug that c value in, you get a 0 as a result. Synthetic division is also known as synthetic substitution. So synthetic division is the same thing as plugging in the value. Like we did on example B, plugging in 3 would have been the same thing as doing synthetic division with 3 on the shelf. So it's the same idea. Synthetic division, get a remainder of 0, then what you divide by is a factor of that polynomial. It's kind of like the same thing. We know that 5 is a factor of 20 because 5 goes into it evenly and has a remainder of 0, right? That's the idea here, but we're still in polynomials instead. So the factor and remainder theorem opens up this idea that if we can do the synthetic division for a problem and get a remainder of 0, then we can decide if something is a factor or not, and that can help us break up a larger polynomial down into polynomials that we are more equipped to deal with. So let's take this problem and say, is x minus 1 a factor of f of x equals 2x cubed minus x squared plus 2x minus 3. And we want to show that with our synthetic division. Okay, so I'm going to set up synthetic division. 2, -1, 2, -3. What goes on the shelf? +1. Run synthetic division with that. So we drop the 2 down, multiply and add. That remainder is that last spot there. It's 0. So what's that tell us about if x minus 1 is a factor of that or not? The yes. The remainder is 0. So that right there is what tells you whether or not it's a factor. Now, what does that do to the polynomial? It takes it and factors it for you. X minus 1, and then the other part is 2x squared plus x plus 3. So it took this polynomial and broke it down from a cubic to start with into a linear times a quadratic. We have tons of tools for solving quadratic. We got quadratic formula. We've got factoring with the x method. If there's not a plain x in there, we could do solving by square roots, completing your square. There's all kinds of things that you can do to solve a quadratic. We don't have near as many tools for solving cubics. So the idea here is to be able to take a factor and break down a bigger polynomial into pieces that are more manageable. And so that's kind of what we're trying to get out of that. So let's get into actually doing that. Taking a polynomial and breaking it down. So find all the possible rational zeros. We'll talk about that as we do this example. And factor the polynomial. And find the zeros. So 2 things there it says about zeros. The first part is possible rational zeros. The last part is the actual finding of the zeros. Okay. So for a polynomial, let's take 2x cubed plus 11x minus 7x minus 6. That's our polynomial that we're going to break down. Okay. The possible rational zeros. Y'all remember doing the P over Q list where you had the factors of 6 and the factors of 2. Yeah, it should have been squared. I said it and didn't write it in. Factors of 6 Factors of 2. All right, so possible rational zeros, you take the factors of the constant term and the factors of the leading coefficient, and you're going to create all of these different possible rational zeros. That doesn't mean they all are zeros of the polynomial, but they're the ones that it could be. Okay, so what are the factors of 6? 1, 2, 3, and 6. What are the factors of 2? 1 and 2, right? The possible rational zeros then, take all the numbers on top, divide them by 1. So 1, 2, 3. So plus or minus 1, 2, 3, 6. Then divide them all by 2. 1 divided by 2 is a half. 2 divided by 2 is 1. I already have that one listed. Don't have to write it again. 3 divided by 2 is 3 over 2. 6 divided by 2, that's 3. I've already got that one listed, so I don't have to write it again, and I'm finished. That's what I've done there is I've narrowed down if this thing has rational zeros, then I've narrowed it down from every number in the world down to this list of 1, 2, 3, 4, 5, 6, 12 numbers, positive and negative of those 6 numbers. We've narrowed it down to those. Back when Coach Mack and I were going through, they didn't let you guys graphing calculators you guys get to use, so we had to just guess and check. You had to pick one, do synthetic division with it. If you got a 0 remainder, yay, you got lucky. If you didn't get a 0 remainder, start over, pick another one, and go from there. So you guys have a nicety of the graphing calculator that can help you determine which one to start with to start breaking down your polynomial. Okay, so with the graphing calculator, what you would do next would be graph that polynomial. So we're going to graph 2x to the third plus 11x squared minus 7x minus 6. And if I'm looking for zeros, what am I looking for on the graph? The x-axis, where it's hitting the x-axis. Okay, how many times is this one hitting the x-axis? 3 times. So it's x cubed. Makes sense that it would hit the x-axis 3 times. The degree of that polynomial helps us know how many zeros we should have. Looks like we're going to have 3 real ones with this one because it hits the x-axis 3 times. So looking at those numbers, it looks like this is like -6 right there. What's that one look like? -1/2, and that looks like +1. I'm going to check one of those. It doesn't matter which one. I'm going to pick the one that I think is the easiest to do division with, right? Which one would be the easiest to do division with? 1 would be easier. So I'm going to hit trace 1, enter. And what happens is I get a 0 as a y value. That means that's going to be a 0 of my polynomial. So I'm going to do my synthetic division with that part first, with that 1. So I'm setting up synthetic division, putting 1 on the shelf, 2, 11, -7, -6. And I'm just doing synthetic division, breaking that down. So that's a 2. No surprise, I get a 0 as a remainder. Okay, it's got to do that. All right. Now, what that does is it takes my polynomial, and instead of a cubic, I now have x minus 1 as a factor, and 2x squared plus 13x plus 6 as the other part of that. So I've got a linear factor, and then I've got this quadratic factor. What do we know about quadratics? Yeah, it's a trinomial, so I can factor it through x method. So that's what I'm going to do. I should end up with the factors ended up with x plus 6, and then maybe what 2x or plus 1 is what I think they'll be. But I'm gonna do x method just to verify that. 2 times 6 is 12. That'd be 13. That'd be 12 and 1. So I'll do 2x squared plus 12x plus 1x plus 6. Group that. And GCF of 2x and 12 would be 2x. X plus 6. GCF of that is 1, x plus 6. So I end up with the factored form of this original polynomial, x minus 1, x plus 6, 2x plus 1. That's the factored form or intercept form. Both of those mean the same thing. Remember, we was talking about intercept form when we did quadratics earlier. So those are the factor. That's the factored form of that polynomial. What are the zeros? X equals 1, negative 6, and negative 1/2. How did I get those from those factors? Yeah, just set them equal to 0 and solve. Notice on our graph, where's it crossing the x-axis? Those same three numbers. Or always cross at all of those numbers. Sometimes it doesn't cross the x-axis 3 times if it's cubic. Sometimes it only cross it once. So all of that's just going to take, practice and getting there. So let's go to a larger polynomial and see what we can do with that. Okay, so that's the idea. That's what we're after here. Factored form and zeros of the polynomial. What we're after. All right, let's take a larger. So we're going to factor and find all zeros. Here's our function. F of x is equal to x to the 5th power minus x to the 4th power minus 4x to the 3rd power plus 8x squared minus 32x plus 48. 5th degree polynomial. So how many zeros should I have? 5 of them. Whatever the highest exponent on the variable is, that's how many answers you're going to find. Okay. Highest number, or the polynomial is going to have 5 answers to it total. So we're going to try to factor that. So first thing I want to do is a P over Q list. There will be quiz questions and test questions and final exam questions that say write the P over Q list or the possible rational zeros. That doesn't take a ton of math ability to do that. They should be the give me problems. So since 1 is in front of x to the 5th, the bottom part's not going to matter because I'm going to just divide them all by 1. I don't have another number to divide by. So I'm just going to get the factors of 48. That's the only ones I need for this. So what are the factors of 48? 1. So we've narrowed that down to a much smaller list than negative infinity to positive infinity. Those are just numbers that multiply times something else to get 48 or divide into 48 evenly. That's what those numbers come from. Because the leading coefficient is 1, you're not going to have any fractions in that list, which is nice. That means we don't have to worry about fractions. All right. Next thing to do is set up a synthetic division with your original polynomial. So we got 1, negative 4, 8, negative 32, positive 48. But I got to find out what to put on the shelf. Back in ancient times, we just guessed and picked one of those. You guys have got a better shot at that. What do we do next? Graph it and find out where it's crossing. Go to y equals, clear that other one out. Go x raised to the 5th power minus x raised to the 4th power. Try again. Minus x raised to the 4th minus 4x raised to the 3rd plus 8x squared minus 32x plus 48. All right, some interesting things happening here. I see this thing crossing the x-axis in one spot. And what's it doing over here? Touches. So what do we know about that zero? It's got an even multiplicity. It's either a multiplicity of 2 or a multiplicity of 4. Because it's 5th degree, so we got to have 5 answers. This 2 could count 4 times or 2 times. We don't know which. How many times does this count?
Either 1 or 3.
Well, either 1 or 3, right? Okay. So I'm going to run synthetic division with one of those and see what happens. I'm going to do the positive 2 because it's easier to do synthetic with a positive number than it is a negative number, right? So I'm going to use the positive 2. So if I'm going to verify that, just trace positive 2, hit enter. I get the y value of a 0. So I know that that is a 0 to this polynomial. So I'm going to put a 2 on the shelf and run it through with synthetic division. So 1, 2, 2, negative 2. Negative 24, negative 48. And there's a 0. No surprise. Now, because that graph bounced off the x-axis at 2, I know I can use 2 again, at least one more time. So I'm going to do synthetic division on this line with another 2 on the shelf. Okay? Because I saw it bounce off the x-axis, that's a multiplicity of even amount. So at least it's going to use twice. So I'm going to run 2 another time through that synthetic division. 1, and then 3, 6. And there's my remainder of 0. So when I did synthetic division the first time, this red line right here got it from x to the 5th power. This is now x to the 4th power. I did synthetic division one more time, and the green line, this first term, would be x to the 3rd power, right? Started with 5th, went to 4th, one more synthetic, went to 3rd. I still don't have a lot of tools for solving cubic problems. I have more tools for solving quadratics. So I want to break this down again. So my question is, do I use the 2 again? What happens if I do? Well, if I use it another time and it works, then I know that it's going to be used a 4th time, right? Because remember, we said it either had a multiplicity of 2 or a multiplicity of 4 out of that. So if I tried the 2 again with synthetic division, just to see if that's going to happen, I'm just going to run it through real quick. Shouldn't take me very long. And that's easy to see that that's not a remainder of 0. It's not 0. It's 30, 40. That doesn't work. So I know that that synthetic division does not work. So I'm going to go back to the 1, 3, 4, 12. And I'm going to do synthetic with what? Negative 3. Put that on the shelf. 1, 0. And there we get the remainder of 0 that we want. So far, this is what we've got for the polynomial. X minus 2, x minus 2, x plus 3. And then that last line is x squared plus 4. There's our factored form so far. Will this factor, the x squared plus 4, will it factor further? I heard a yes and a no. What does it have to be? A difference of squares, which is a minus. Because it's a plus, that won't factor any further. Okay? How do I solve and get the zeros that go with that? Okay? So I set that equal to 0, x squared plus 4. And I'm going to solve that. So subtract 4. and then take the square root of both sides. What happens when you take the square root of a negative? Imaginary numbers, so that plus or minus 2i. Okay. So here's our factored form. The zeros, let's list those. X equals 2 with a multiplicity of 2. X equals negative 3. And x equals plus or minus 2i. How many is that? 1, 2, 3, 4, 5. 5 solutions. The original degree was 5, right? Excuse me. So that, whatever the degree is, we should be finding that many zeros to the problem. Okay. Y'all remember doing this in Algebra 2? We did a good bit of it in Algebra 2. So a lot of repeat here on that. All right. So steps for finding the zeros of a polynomial. First thing you're going to do is the P over Q list. Be able to make that list because there will be a quiz question, at least one or not two, and then test questions that will be just right the P over Q list. So make sure you can do that. Whether you use it or not,